So good morning students. So today we are going to start lecture number 8 of kinetic theory of gases. So in this class what we will be discussing means basically main point about what do we known as mean free path. Mean free path. What do we know as mean free path and what is the expression for mean free path? Okay. Now today's concept mean free path. Okay. Now first of all, gas molecules will be vibrating and moving randomly. Clear? Here one molecule, here one molecule, here one molecule, here one molecule. Clear? While in motion, okay, they may collide with each other. That means this molecule may collide with this one, later it may get collided with this one. So once after colliding here, next collision let us consider here it is colliding. This is nothing but this is a path where it can moving freely. No collision. Freely this atom, that means basically this gas molecule is colliding with this gas molecule. Later this molecule is here and again it will come here. So whenever it is in motion, this path is nothing but this is the path where it is moving freely. So this path is known as free path. Basically this path is nothing but what? A free path where collision is not occurring. Yeah. Now when collision happens, velocity will change. Clear? Probability is there, okay, where velocity value will be changing. Okay. Now velocity will change basically in direction, and in few cases value will be changing in what? Magnitude also. Clear? Velocity is magnitude as well as direction values will be changing. Clear? Now the distance where that molecule is traveling, okay, between two successive collisions where I had drawn earlier diagram, that path is known as what? A free path. Okay. So free path means what we can tell? Free path means distance traveled by gas molecule between two successive, one second, free path. Distance traveled by a gas molecule, distance traveled by a gas molecule between two successive collisions. Between two successive what? Collisions. Now mean free path means mean distance traveled by a gas molecule between two successive collisions. Clear? Okay. Now imagine that these are gas molecules. Gas molecules, let us suppose this is the molecule which is a royal one, we can tell. Okay. And here we are having some more molecules. No. We are telling that, I am specifying that this molecule is going and colliding with here, first one. Okay, this red color molecule. This is red color. These all dots are what? A blue colored one. This line is nothing but a black colored one. Clear? This red color molecule right now it is here collided. Now it may change its direction and red color molecule may go up to this point and it is hitting here, this molecule. Are you getting the idea what I am trying to tell you? No. For red particle, for this molecule, this is first collision, this is second collision. Okay, two successive collisions happened. This is nothing but what? Free path. Let me call it as lambda 1. Okay. Right now this red color molecule is here. Now again it may change its direction and it may go up to hit this point. This is second collision, third collision. This may be as lambda 2. Now again, that red color molecule may hit this one. Okay? First collision, second collision, third collision and fourth collision. Between third collision and fourth collision, lambda 3. Again now red particle may come and hit with this one, lambda 4. Clear? This distance is greater, smaller, smaller, again greater. Clear? So mean free path is denoted as the letter lambda, and this lambda can be directed as mean value of free paths. Free paths we are having lambda 1, lambda 2, lambda 3, lambda 4. For this 4 we have to take means sum of these 4 divided by 4. In practicals we will be doing now sum of 3 divided by 3, like that. Sum of these 4 values divided by 4. Lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 by 4 for 4 collisions. If we have n number of molecules means n number of free paths divided by n number. So mean free path is nothing but what? Average distance traveled by a molecule between successive collisions. This is known as a mean free path. Clear? Shall we go to derivation of this mean free path? Okay. Okay. How to derive? What is the expression for mean free path? Listen. Expression for mean free path. To derive expression for mean free path, we are assuming that our gas molecules, what we are considering, our gas molecules are hard spheres basically. Just to derive the concept, we had taken all these things, and we are assuming we are having one cylinder type structure over here. We are considering an imaginary cylinder whose radius is d. This value is d, and here we are having one molecule which is nothing but the diameter of this molecule is d. Okay, and here we are considering one more molecule whose diameter value is d basically. Okay, and this is one more molecule we are considering. This is also diameter d only. Let us name these values. This is our sphere A. This is B. This is C. Okay, getting my point? And this is closed cylinder over here. This side, closed one. Okay, closed manner. So my diagram little bit you have to get adjusted. Okay. Now these molecules A, B, C, these molecules we are considering what? Hard spheres. these molecules what we are having, these molecules I am going to consider these molecules as what? Hard spheres. Okay, now, and we are assuming that only molecule A is in motion, B and C are at rest. And from the axis means axis which is passing through center of the cylinder, this line. This is nothing but what? Axis of the cylinder. From axis of the cylinder, molecules, listen, from axis of the cylinder, this complete radius is d basically. Okay, now we had considered this molecule A is in motion and it is moving in a straight line, B and C are at rest. Okay, now this considered molecule A, this molecule will collide with all the particles which are at a distance d with the center. Clear? Now, if here particle is there means obviously it will collide, correct? No? That means from the distance d with its center means the particles which are present over here, there also this particle, this molecule A will collide. That is the meaning of this. And capital D as the value which we had chosen for diameter of each molecule. Molecule A, okay, will collide with all the other molecules, okay, like this molecule B, like this molecule C, whose centers are at the distance D. Okay, so here if I consider means this part will be d by 2, this part will be also d by 2, final value will be d. Okay, now if this molecule A, what I had considered here is moving for certain distance L, let us choose length of the cylinder as L. Okay, if it is moving with a certain distance L, then it will be colliding with all the molecules which are in that volume. So volume of the cylinder is nothing but what? Pi d square L. Basically pi r square, here r value is d, that's why pi d square L. So how many collisions are happening means how many number of molecules are there, those many collisions will happen. So number of molecules are nothing but, this is nothing but a volume. So number of molecules is nothing but number of molecules will be n times of pi d square L. Clear? Small n pi d square L. Clear? Where n is nothing but, what I am going to tell you, this n is nothing but number of molecules per unit volume. Okay, we'll come to that point, why we are telling this as unit volume case. So these many number of molecules are there means these many collisions will occur. Yeah. So now lambda is nothing but what? We know that lambda is nothing but what? Distance covered divided by total number of collisions. Distance covered is nothing but L, total number of collisions is nothing but this value. This is number of molecules which is also equal to number of collisions. Okay, so n divided by n pi d square into L. So L will get cancelled, value we are going to remain with n pi d square. Okay, lambda is equal to 1 by n pi d square is the formula which we had considered when considering all the scenario like A is in motion, okay, B and C are at rest, and again A, B, C are hard spheres like that. But what our scientists said that is not only 1 by n pi d square, that is 1 by root 2 times of n pi d square. Shall I erase this part completely? Diagram is clear to you? Okay. So value is what we got, lambda is equal to 1 by, what is the formula we got? N pi d square, 1 divided by what? N pi d square. But what our scientists said, this is not only 1 by n pi d square, it is root 2 times of n pi d square. Clear? Don't worry. Now Small is nothing but what I had told you, that is nothing but unit volume. Okay, that means number of molecules per unit volume. So what I am going to substitute in place of n means, this is nothing but number of molecules per unit volume. Means if we are having 1 mole of gas, means this is Na divided by number of molecules per unit volume, means Na divided by per unit volume, means I should have to divide this factor by V. Okay, so lambda will be equal to what we are going to get. Lambda is equal to 1 by root 2 times of Na by V into pi d square into pi d square. This V will come to numerator now. Clear? Denominator of denominator will come to what? It will be coming by numerator. Okay. So lambda we are going to get what? A V whole divided by root 2 Na pi d square. If I multiply and divide by P means I am going to get here Vp divided by this factor. So we know that PV is equal to what? PV is nothing but what? RT. Correct now? We know that PV is equal to what? RT. So RT, PV is equal to RT divided by root 2 Na pi d square P. Now R into T, we know that K is equal to R by N. So R will be equal to Kn. So in place of R I will be substituting what? A Kna, where N is nothing but Avogadro number, Knat divided by root 2 Na pi d square P. What all the things will get cancelled? Na will get cancelled over here. What formula is remaining now? Lambda is equal to, come on, Kt divided by root 2 pi d square P. Kt divided by root 2 pi d square P. This is nothing but our expression for mean free path, which is very important from competitive point of view. Where K is nothing but what? A Boltzmann constant. T is absolute temperature. This is a constant factor. Pi is a constant factor. D square. D is nothing but diameter of molecule. Remember, D is nothing but diameter of molecule. And this P is nothing but what? Pressure. Clear? So this is the case about mean free path and its derivation. So in final exam also, for 5 marks if they ask means you should have to write this much. Clear? Okay. So kinetic theory of gases. So we have discussed so many number of factors in kinetic theory of gases, and one more factor we should have to discuss, that is nothing but what? Experimentally kinetic theory of gases has been proved by Brownian motion. Brownian motion. So what do we mean by Brownian motion? Listen. Brownian motion is nothing but a zigzag moment. Brownian moment means zigzag moment. So zigzag moment of small particles. Okay, the zigzag moment is for which particles? Small particles. Zigzag moment of small particles. But this will be not in case of this one. It will be in case of what? Basically a fluid. Okay, small particles in fluid. Okay. So what do we mean by Brownian motion? That is a zigzag motion of small particles. Okay, small particles also you can tell, otherwise small suspended particles. Okay, in a fluid is known as what? Brownian motion. And this zigzag motion will be not orderly, it will be a random zigzag movement. A random zigzag movement of small particles, okay, small suspended particles basically in a fluid. So for 1 mark or something, if they are asking the definition, means you should have to write this one. Okay. Clear? Okay. So now we are going to discuss numericals based on VRMS. Shall I erase this part? Okay. Listen. Find VRMS for hydrogen molecule at 27 degree Celsius. At 27 degree Celsius. Yes, how we can calculate? Can you think about this question? How we can calculate? They had given hydrogen molecule which is at 27 degree Celsius. Yes. What is the formula? Listen. In our previous class, we had discussed that formula for VRMS, not today's formula. Clear? Don't quickly rush for 1 by root 2 like that. Okay, KT by root 2, that formula. So VRMS, what is the formula? What formula we had discussed in our previous class? I hope in second class only we had came across this one. So VRMS is equal to root of 3RT divided by M. 3RT divided by M. Now substitute the values. 3 is a constant. 3. What is the value for R? 8.314. Okay. T value is nothing but for temperature, but you should have to keep that 27 degree in Kelvin scale. That means this value will be 27 plus 273. Value will be 300 divided by M value for H2 means value will be how much? 2 grams. 2 into 10 to the power of minus 3. Okay. Solve it and tell me what answer you are going to get now. So almost 1.9. Check it. 1.9 into 10 to the power of 3. Solve it correctly. 1.93 into 10 to the power of 3 meters per second. 1.93 into 10 to the power of 3 meters per second. Clear? Shall we go to one more problem? Copy it down, note it down. Okay, next question. Shall I erase this part? Okay. If VRMS value for hydrogen is X at some temperature, okay, then find VRMS for O2 at same temperature. Okay, how we can proceed with this problem? Can you just think about it? If VRMS for H2 is X at some temperature, find VRMS for O2 at same temperature. Same formula. Okay, VRMS is equal to root of 3RT divided by M. Ratio you should have to choose my here. Okay. So VRMS value for H2 is given it as value is how much? X. Correct, no? Okay. Next, one more they had asking VRMS for oxygen. So VRMS for how we can calculate this one? Just take the ratio. So VRMS for oxygen divided by VRMS for hydrogen gas. Oxygen gas as well as hydrogen gas. That means what we are going to write formula here, 3RT divided by M whole divided by root of 3RT divided by M. R is constant, temperature is constant, this value will be becoming constant. This is for H2O2. Okay. So V for O2 divided by V for H2 is nothing but a root of MH2 divided by root of MO2. Okay. So MH2 value will be how much? 2 into 10 to the power of minus 3. This is value will be 2 into 10 to the power of minus 3. This value will be for oxygen means value will be how much? 32, no? 32 into 10 to the power of minus 3. For oxygen value they are asking, for H2 they had given value as X, just cross multiply. PO2 is equal to X times of root 2 into 10 to the power of minus 3 divided by 32 into 10 to the power of minus 3 means this ratio will be how much? Here 10 raised to minus 3 will get cancelled, 2 1 are 2, 16. That means VO2 is equal to root X times of 1 by root 16. Root 16 is nothing but what? 4. Root 16 value we know that 4. So final value we are going to get how much? X by 4. Okay. This is for which one? O2. This is for VRMS for O2 at that same temperature. V for O2 at same temperature. So practice well, okay, and prepare well for your exams. Thank you.